Yeah. So my name is Owyn. I work at MySpace, and I'm one of the guys who works on the messaging team, the MySpace mail team. And before I get started, I wanted to give you kind of a quick background, a statistical background on MySpace. MySpace is a ubiquitous social network, pretty much. We're in 27 countries, 24 languages. We have about 110 million active users, although 380 million total users. And we have 4 to 6 million concurrent users during our peak times, which are between like 5 o'clock and 8 o'clock every day. Or maybe it's 9 o'clock. I can't quite remember. A messaging statistic, we have more than 5 million users who have 1,000 messages in their inbox stored. And we have 160 million messages sent daily across the entire web application. So based on some of that awesome, exciting information, I wanted to get started. So one of the things we're going to be talking about today is obviously the application you may have seen at the keynote. And you might be asking, why did we choose Gears to start building this application? And a couple of the main reasons are, it's like on the bleeding edge of what the HTML5 standard is about, and the Gears team is working with the standards body to try to really build support for what they're offering, which is great. And features such as building a SQL database engine, which has full text search, which is a really amazing feature, and we're leveraging heavily, as well as threads, real worker threads. So if you want to have like computationally intensive offline processing, it's actually a possibility with this plugin. It's an open source piece of software. It ends up, if Google, heaven forbid, decides to not support it anymore, we as a company could take the source and continue to move forward with it if we want to. And it's also a security blanket because of that fact. So we can eyeball the code and make sure things are up to par and all that. I'm not sure if you saw the keynote, but Alan, who's my boss's boss, was mentioning that they came to the developer days, which is now Google I/O, last year, and they were really excited about it. And so we've started like prototyping things a year ago, and since that time, things have been maintained. The feature set has been maintained and improved. There's been a few iterations of the Gears plugin, and that's offered more and more support. Worker threads have been dealing with worker threads has been improved, debugging, et cetera, et cetera. And generally, it's awesome. I think one of the things that we're really excited about is, and one of the things that like Vic and everybody at the keynote was trying to hit home is really improving the browser as a platform for application development, and this really gives us the opportunity to do so. So moving forward, so I guess if you hadn't seen the demo at the keynote, you'll be seeing it in a sec, but basically a general kind of summary of what MySpace Mail with Gears Search is bringing search to users of MySpace Mail. They don't have that currently, or they didn't until this morning when we launched the feature. They also didn't have the ability to sort their mail except for descending via date. And so we wanted to give them the ability to sort and find their unread messages, have them bubble to the top, sort by senders, and et cetera, et cetera. And at the time, one of the reasons why we hadn't put search on the server is at the time we felt, for a long time, we felt it was cost prohibitive, and this actually gave us a way to iterate a feature quickly and bring it to our users also quickly. So talking about the keynote and how they came last year, I wanted to give you a quick example of or a quick little story. After the developer days last year, Dan Farino, who's a good friend of mine and a colleague, he ended up coming back and used Google Gears to quickly prototype mail search. He used Grease Monkey, which is developed also by somebody from the Gears team, Aaron Broodman, and used screen scraping to actually pull down information onto the client and demoed this around to team members and product people and our executives, and they're all really excited about it. Dan, in addition to being friends with puppets, he's also done quite a bit of work for our infrastructure as a whole. He's created this server agent service, which is really based on, I don't know if you guys are familiar with the MapReduce concept that Google has written papers about and implemented in their systems. But it basically does the same thing. It aggregates a lot of data for us so we can monitor our large web farm. So enough about Dan. He's a great guy. Fortunately, he's not here today, which is a shame. But I wanted to give you a quick demo of Gears itself. Or, excuse me, MySpace Mail with Gears. So let me log in to MySpace with an account, my work account. And I currently don't have Gears installed, but I wanted to give you guys the full first run install experience. So if I go to the inbox, note up here on the top, there's a little pitch message that says, hey, we have really cool features if you download the plugin. Why don't you go download the plugin? And so you're really excited about it, and so you end up clicking the Find Out More button, which gives you an advertisement, obviously, but 3 wonderful install instructions. And you go ahead and click on this because you're so thrilled. And you go to Get Gears, which takes you to the Google page to install Gears. Click on Install Google Gears. We love Google, so we want to help them improve everything by sending them statistics, so we check that box, and we save the file. And it looks like I've already downloaded it once, but let's do it again. Go ahead and, so you click Open, and you hit OK. And Gears automatically connects to the internet, gets the latest version, and quick as a minute, it's already installed. I click Restart Browser, and I go ahead and hit the Windows key to get my browser back up. And I browse back to MySpace. Log in as me. Oops. If I could type my password. Go back to the inbox, and lo and behold, wow, the message pops up saying, hey, you have Gears, we want to leverage Gears, but please don't do this if you're on a shared machine. Now that's one of the key things that we want to get through, and I'll talk more about later in the session, is the shared computer scenario, the shared OS login scenario. Gears locks down your information per operating system login, but our users and lots of applications users likely use the web through a shared OS login scenario. So we want to make sure that they're completely aware when they can that they're going to be downloading data locally and that it might be available to other people. But we love MySpace, we love Gears, so we're going ahead and go do that. And right off the bat, I only have 12 messages, so that was really quick. But I can search right away. So I type in Owyn, and there's my personal account, and those are all the messages from Owyn. I can also find all the unread messages from Owyn by sorting, and lo and behold, 2 unread messages. Really, really exciting. So I'm going to show you the shared computing scenario. I'm going to sign out real quick and sign in. Hello. And sign in as, I love our ads, sorry. Sign in as another account. And this account has more messages, as the Wendy's guy. And go to the inbox. And note that it doesn't pop up the standard Gears dialog. The standard Gears dialog only shows up once per OS login if you've already accepted it. It doesn't show up for anybody else, but we want to make sure that every user in the shared scenario is aware that we might download messages to them if they want us to. So we give them the opportunity to opt in or out, but we pop our own dialog and give them a lot more detail. But obviously we love MySpace and we trust this computer, so we hit yes. And one of the things that it's kind of hard to see, but you might see a blurry number incrementing, and that's because we're using worker threads to pass messages. So as we index data transactionally, and we use worker messages after every transaction commit to send information back to the UI thread to update. And if you notice, I'll let this run one more time. We throttle our information, throttle our requests too. One of the big things that we're concerned about at MySpace is scalability and making sure that we can deal with scaling out to the user's needs. And so we end up throttling these requests because the request to pull information down from the server is it's actually a very expensive query. So we both throttle on the server and the client. But as you can see, when we're on the client corpus scenario, you can see how the count is incrementing, the pager is counting up as you have more pages of messages. It's really thrilling. I'm really excited about it. And you can search and sort right away. So these are all test messages. We're using a British insult generator. So I'm going to look up naive. And note that the top subject says mad, drooling, incompetent. But if I go in and read the body, it says, my dear, hopelessly naive inbred, yada, yada, yada. And so it did indeed find the word naive. So that's a testament to the Gears team and their full-text search capabilities. So now that we've seen the demo and are extremely excited about it, let's go back. I'll give you a little explanation to really understand what it takes to build MySpace mail search on the client. You kind of have to have a basic understanding of MySpace mail's architecture on the server side. So key things to be aware of, there's obviously our users, and they browse to us through the internet, obviously. And MySpace is a farm of thousands and thousands of servers. And they're broken up into chunks, which we call VIPs, virtual IPs, I guess is the acronym. And the messaging VIP has about 390 servers dedicated to serving information to our users. The messaging, the primary database it talks to is the messaging databases. And early on in MySpace's life cycle, we had one database to serve all of the mail for users. But after a particular point in time, around 6 million users, that ended up not being able to scale out effectively. So there was a decision to partition information and into what we call the federation. So we end up having one messaging database for every million users at MySpace. And we have 380 million total users. So we have 380 messaging databases. Now, messaging itself also has a lot of business rule checks because we want to make sure people who are over 18 aren't sending mail to people who are under 18. And if you have no friends, or if you're sending mail to people who aren't really your friends, we filter it in different ways and stuff like that. So we have a set of feature databases, which are not diagrammed here. And we also have a set of shared databases with a cache store in front of that. Now, the shared database and the shared cache store have information regarding your friend list, your email address, whether or not you've blocked users, et cetera, et cetera. So we make checks to those prior to committing messages to the mail database. One of the other things that we do, and we just recently introduced, was the commits and the sends go through an asynchronous pipeline. And one of the major reasons for that is because we want to be able to put in more robust spam filtering capabilities and et cetera, et cetera. It's really exciting. So moving forward, so I think that gives you a fair, simple understanding of the messaging application system. So what does it take to add Gears support and really bring data down to the client? Now, the first thing is we need a web service endpoint that is client accessible and secure. Now, the web service endpoint that we have is secured the same way your application is secured, through your cookie. It's an encrypted cookie. Then we rotate keys very frequently and exciting stuff like that. One of the things that we didn't offer previously, you saw on the message list there was a list of headers, and we get those in batches. But we never had the capability of getting actually full message data in batches. So we had to add that capability. And that's really the most expensive call that we have in the system. And so that's one of the reasons why we want to throttle it, and I'll kind of give you some detail about that. One of the other things that we've added are tables to provide user-machine association. Like we saw here, there's you can have multiple users on the same machine, but you could also have a single user across multiple machines. Like I have my work laptop, I have my home PC, I go to coffee shops and steal other people's stuff, and it's really exciting. So I want to make sure that we track the user-machine association individually, because we need to have information about users on the machine in which they came from. So we have a table that does that and stores on the server whether or not they've enabled Gears for that particular machine, the last time they made requests, etc., for server-side throttling, as well as gathering metrics and all that exciting stuff. And the last thing, MySpace Mail itself is not only an insert-delete system. There are updates that occur. So you can move your messages from one folder to another. Whenever you read a new message or reply to a message, there's actually a status that both you as the sender, or excuse me, you as the recipient, and the sender of the message see, and those get updated. And so we actually had to add a system to our mail database to track those updates. So that ended up being a trigger-based system that, intelligently knows if you are an enabled user using Gears, then we'll start adding things to a log table that we query periodically. So that's kind of a summary of what we did on the server side. On the client side, this is kind of a basic diagram that kind of separates out what we do from a worker thread process and a request process. So the web client process, meaning the browser's UI thread, is responsible for all of the AJAX requests to the server web service. And what they do is data gets returned in JSON format, and the web client farms out that JSON to either the indexing worker thread or the status update worker thread. And those are throttled in different ways. And like I said, they process them transactionally and write to the database directly. And one of the things to be aware if you're doing this kind of thing is because of the fact that Gears itself is also secure by the same origin policy, you need to make sure that your worker threads, if they're accessing your local database, are being served from the same origin. Otherwise, they're going to be attempting to access a database under a different domain, and that just doesn't work effectively. Let's take a look at my notes just to make sure I'm not missing anything. Oh, yeah. One of the other things that we tried to make sure we did was in the web client process, we wanted to make sure that the class that's dealing with Gears directly doesn't have direct interaction with the UI. So what we ended up doing was abstracting a lot of the UI modification functions with callbacks. And I'll give you a little bit more detailed information on that in a little bit. We're also, like I said, throttling. So the indexing process is the primary process that's really important. So we want to get new messages quickly, and so particularly for first-time users, we want to index your newest stuff first and go all the way back to your oldest stuff. But we also want to make sure that as new messages come in, we start indexing those new messages too, because the newest messages are the most important messages. And so we throttle the indexing process. We grab up to 100 messages at a time every 30 seconds, and we throttle that both on the client. So if you grab less, if the service returns less than 100 messages, it exponentially backs off and says, okay, I've got a full body, so I'm going to wait for a little while. And on the server, we also have a less expensive check to make sure that the last time you made a request is older than 30, later than 30 seconds from when you did previously. And if you haven't, then it just returns nothing, which also causes the client to exponentially back off. And if you have, then it makes the expensive call, which is the batch, full body call, and then returns it to the client process. Same thing with status. Status updates, we decided to throttle that and make that less frequent. But what that ends up being a different call, which goes out to the web farm. And on the server side, like I said, we have the log table, which has timestamp information. And the last timestamp that you made a successful request is stored in your user machine association table. And so we end up getting up to 500 changes since that timestamp, which pulls it from the log and then returns them down to you. And periodically those log tables get deleted. So we have to store data locally, right? So there's a local SQLite schema that we end up using. It's broken into 5 tables. And currently, if you have a multiple user to one machine account scenario, all of the data is stored in one database. Brad Newberg, who's a member of the Gears team, had a great suggestion, which we haven't done yet, which was actually partitioning your data by user. So you have individual databases per user, but we're not doing that right now. So what we end up doing is we have a user settings table, which stores your user settings. which has the machine ID that the server has given you, whether or not you're enabled, the timestamps for client-side throttling. So if you refresh the page, we can pull the last time you made a request. And some other data related to startup. So the oldest message IDs to know when we've indexed everything. The last server total count, so our client-side pager can, be relatively accurate. And the user ID in the user settings table is related to the recipient ID in the message metadata table. So the message metadata table stores a bunch of information about the messages that you've downloaded, including the author ID, your folder, which is an integer that corresponds to your inbox or your trash, status, which is also an integer that corresponds to that. And there's a relation between the row ID of the message metadata table and the row ID of the full text indexing virtual table, message data, so we can have a relation when searches occur. So you do a full text search, and the row IDs are the same, so it pulls back in a query, et cetera, et cetera. We also pulled out author data into a separate set of tables. And the main reason for that is we currently lazily update author data. What ends up happening, MySpace users themselves, they have a lot on their mind, and they like to change things quite a bit. And two of the things that they like to change are their picture and their display name. And so we store that information, but instead of querying that information regularly to get it pulled down so your local corpus is always up to date with your latest friends' information, we only do that whenever they send you a new message. But we do store it separately. So messages, who share an author, you don't have to update several messages. You only have to update the one author. So the architecture of the client-side classes is fairly simple. Like I mentioned, search messages is a class that ends up abstracting direct gears interaction. So what it ends up doing is it does all the database initialization. It gives you the function to call search and query the information from the local database and return it and it passes it to the UI callbacks you provide. Like I mentioned, it ends up abstracting UI interaction through the use of callbacks. And it also encapsulates the next class, which is the local messaging state manager class, which stores a bunch of state information about the UI, counts, what page you're on, et cetera, et cetera. Like you saw, the counts get updated on the client side in this state, the state manager class, and it's the publisher to subsequent classes like the client pager class, which subscribe to events. So when state changes, it publishes out the fact that it changed and itself. So the subscribers to that state can update themselves, like you saw with the pager, the count incrementing and the pages incrementing and all that exciting stuff. Now, one of the embarrassing things right now is that all of the functions that we use to do direct UI interaction are global in scope, and that's kind of embarrassing, but that's just the way it is. But so if you guys can feel free and heckle me, but wait till the end of the thing, please. So let me give you a quick walkthrough of some code. Now, this isn't exactly the full code, but it's kind of broken up into chunks. So this is a summary of kind of the search messages class. As you can see, at construction time, passing quite a few parameters, including all of these callbacks at the top. Is this big enough for everybody, or should I make it bigger? Bigger? Okay. Let me, Notepad++. Don't fail me now. Is that better? Are we good? You guys are a great crowd. Thank you. So moving forward, as you can see, there's quite a few callbacks. A lot of arguments. Probably not the best paradigm, but that's okay. So we initialized several fields here. Now the key things to note are the strings field and the URLs field. Those are both. So the strings field, like I mentioned, MySpace is in 27 countries and quite a few languages, and so making an application localized is really important to us. And so we have a system on the server side to take strings and go through the resource translation process. And so this is where we pass them down to gears so they can be leveraged through the application. And the URLs are a similar thing that's configuration based. That stuff's all exciting. This is where we instantiate the state manager. And this is sort of the meat that really makes sense as Gears related. So this is where we end up checking to see if Gears is installed. One of the things we also did, and I'm not sure if you heard, when we launched the application today, we launched it to everybody who has Gears installed, but we also pitch it to certain people, and those people are people who have more than 5,000 messages. And so on the server side, we check to see your server message count, and then we basically pass in this bool that's whether or not you're eligible. And if you are eligible, then we give you the Gears not installed call, which shows that pitch message. Excuse me, that's terrible. The pitch message to sell you to install Gears, and then we return. Otherwise, we do a version check. So if there's, we support version 3.14, but just version 3 and above. And so if you have less than version 3, we treat it like you haven't installed it, but we also change the text a little bit because you do have a version. Down here we do the permissions check. Has permissions doesn't pop the dialog, but get permission does. And so what we end up doing is checking for permissions and then passing in some strings, like I said, the localized version of the MySpace cell, as well as the URL to the PNG. And that pops that Gear-specific dialog, not the floaty fade-out dialog. And then based on that, the return value is whether or not they've approved or denied the application. So if they've approved it, then we treat it as a first-time install and move forward. If they've denied it, then we return and don't harass them anymore. So then we instantiate the database, initialize the worker pools through some of these functions, and set up some first-time install stuff. So that's all well and good. If you guys want to dig in deeper, I can give you the URL to the source, and you guys can make fun of me about that. But this is basically how we initialize the worker pools. We're using the create worker from URL function, which is a really handy function, so we don't have to make like direct AJAX requests to get script. It sort of does it behind the scenes, and so that's really interesting. And that ends up giving you the worker ID, which we then send messages to. Like I said, this is the arbiter for messages between the workers and the UI thread. Let's see. So here's sort of so this is the callback that happens when worker messages get passed back and forth. And so we have a message string which gets eval'd, and that's probably not awesome, but that's the way it is. The worker ID in which it came from, and we go ahead and have a few different commands that then do various things, like the count update, which is what you saw that updated the pager and made it all fancy, and everybody was excited. Is what gets sent back from the worker after every transactional commit when you index a message. That sets the total message count and the total server count, and then it calls the callback, passing the searcher to the callback, so it can get strings and get information about the UI state, et cetera, et cetera. There are several other ones too, like index complete. That's when an index pass is done. So after it indexes the first 100 messages or every 100 messages, calls that. And I think the real key thing that's interesting here is the query itself when you're searching. Now, because and I'm not a SQL guy, so if you guys are SQL guys, please make fun of me later. But when we're searching, full text searching across multiple full text tables, the only way I could find to do it effectively was with the monster union query. So we end up selecting and joining both the metadata table and the data table. And then because we have to also search for authors, as you saw, I typed in Owyn and found messages from Owyn. We do that ugly union, which ends up joining against the author table. And then for the pagination, we do a limit. So we limit to 10 records, and depending on what page you're on, we use the offset clause to jump from page to page. This is the same method that we also use to sort data when you're not searching, because you can sort your data, your local corpus, no matter what. And so depending on whether or not your UI state has a query, will indicate which which query you're actually using, or which SQL query you're actually using. If it does have a query, then you use the big monster nasty one. If it doesn't, then it's a little bit easier. From a security standpoint, the Gears documentation talks about this, but you really want to pass your parameters through. I'm not exactly sure what it's called, but using the question mark syntax, because the Gears execute call massages that information and makes sure there's no SQL injection. The one thing you can't do that with is like what we're doing down here, the order by clauses. You can't pass those in through those kind of parameters. And so the get sort method and the get sort direction method, ensure that there's based by comparing against an enumeration that you're only doing it against valid calls, or making a valid call there. So that's that. There's probably more stuff, but like I said, if you guys are interested in digging in really deep, you can either ask me at the end of the session, or you can look at the code, because it's all out there. The next thing I was going to give you a quick intro into is the worker, one of the workers themselves, and how you instantiate that. So this is our indexing worker. So what we end up doing when you create a worker function, or a worker pool thread, you have to use this syntax by giving it an on message. There's also the on air handler, and you pass in the function arguments are message and then the sender ID. And what we're doing locally, and one of the reasons why we need to run these from the same origin, is because we're accessing the database directly here. We instantiate the database, we eval the message that gets passed to it, and then we record a bunch of information, and then we iterate over the messages themselves and transactionally do an insertion. And like I was showing you, this is how we send the update message back to the UI thread. So the count increments through just the send message call, and we pass in the if we can scroll over to it, the sender, which is the origin ID. And then at the end, like I mentioned, also there is we send another message when the full loop is complete, and that lets the UI know that we're moving forward, et cetera, et cetera. So I guess that's going over the code. It's also going over the worker pool code. One of the key things I wanted to talk about is security, because security is really important to MySpace, security of our users. And bringing data locally is a really new thing for us, and it caused quite a bit of concern when we were thinking about doing this. And I'm sure you guys all know that Gears secures your local databases per operating system login, but MySpace itself, there's quite a bit of a chance that users share one operating system login but have their own MySpace accounts. And so we're trying to figure out ways to ensure that users wouldn't be downloading data locally in a scenario where they wouldn't want to be doing that, which we actually explored leveraging data encryption. I don't know if you guys are aware, but like movable type has several encryption, JavaScript encryption algorithms out there. Dojo implements them in certain cases. But one of the things that we had to do was because we wanted to offer a search feature, we had to find something that really just obfuscated information. So TEA was an algorithm that we looked at, and we kind of borrowed the movable type implementation of the TEA encryption algorithm. And what that gave you was like per string matching. So when I typed in, like dogs, and ran it through the TEA algorithm with the same key, it would come out obfuscated, but it would match the local data if we did a space-delimited split and encrypted every word with that same key. So that had fast search lookup, but it was also very expensive on the client, which one of the reasons why we moved it to a worker pool thread when we were testing it. And it also prevented us from doing prefix searching, which is why the filter as you type stuff, because dog may get obfuscated to one set of characters, where dogs gets obfuscated to a completely different set of characters. And so we decided we prefer to provide a better user experience to the user, and the way we've encouraged security is by making sure the user is acutely aware that they shouldn't download data in a scenario that they're uncomfortable with. That's why we have the Gears dialog that says that. That's why when you log in, when somebody else has accepted the using Gears in MySpace, that we pop up that dialog again and store the fact that they've decided not to do that, because that's very important to us. So like I said, encryption is a possibility, particularly if you're not using full text search. But it's not, in our opinion, at least in my opinion, not necessarily our opinion, it's not worth sacrificing features for. And so like I also mentioned, the web service is locked down to logged-in users. And so we pass your encrypted cookie every web service request and verify that you're you and you're requesting your information. And we throttle requests both on the server and on the client to avoid DOS attacks, et cetera, et cetera. And one of the big things that Gears also offers, and we might take advantage of this in the future, is the ability to have cross-domain workers. So you could, like, we have separate virtual IPs and separate subdomains for our various features. So messaging is one subdomain, friends is another subdomain. If we decided to start storing our friend data offline through the friend subdomain, messaging could theoretically leverage that by using cross-domain workers. But we're not doing that right now because all of our local data is stored in the one domain. And so we want to lock those workers down as much as possible. Let's look at some notes. Yeah. So that kind of comes to sort of future possibilities of MySpace with Gears. We're really interested in seeing how this plays out, how our users take to this, how the tech world takes to using Gears on MySpace. But we've had some ideas and how we might be able to leverage Gears in the future. One of those is friend search for our power users. We have a friend search feature that's available to the majority of our user base, 98% of our user base. But we also have power users, which are users with greater than 5,000 friends, like big bands, our product profiles like Coke or T-Mobile or Colgate, and also popular users like Dane Cook, for instance, have a lot more friends than 5,000 friends. And, they may or may not want to search those friends. And so we could leverage Gears to bring that friend information down to the client. And that actually provides us a lot of other possibilities if we have friend information locally. I mean, you could theoretically leverage it by, doing some cool features that search your local page and, highlight friends and give you information about those friends if you have the data locally or whatever. Some of the other things we've been considering over the long term are more messaging enhancements, more optimizations. Right now, we're only searching and sorting locally, but possibly loading data locally if you have it, so you're not making server requests, or bringing messaging offline entirely. We're not using the local server capability right now. We're only really using the SQL full text search. But if we end up using the local server and robustify, if you will, our local SQL stuff, we could theoretically have users who use MySpace Mail completely detached from the internet and still work like they're attached, and then when they connect, it moves information forward. Now the other thing, MDP or Open Social MySpace is something that we're promoting heavily, and if the plugin becomes ubiquitous, and also if we decide to start partitioning our applications via subdomain, it might be useful for MySpace developers to leverage the Gears plugin. But because we're all serving all of our applications from the same domain, you need to be completely aware that you might be able to access other people's information and vice versa. So that's something to think about. So when Gears is a good choice, like what we've come up with is when Gears is a good choice to leverage for an application is your user base is likely to have the plugin. That's kind of the whole ubiquity thing. We'd like to promote Gears and get Gears in as many places as possible, because it really makes us web developers, gives us a lot more tools to play with. So that's something that we're working on, hopefully. Also, if you're working on an enterprise application and you have a lot tighter control of your user base, you could maybe push the plugin out to everybody. That might be something to think about. And one of the things that we ended up doing and realizing was the functionality that you're adding, that Gears is giving you, is compelling enough to warrant selling Gears or pitching the install. And I think search with Gears and mail is that, because users didn't have that before, and so it's really something that we hope will encourage them to do so. So when building your own application, a couple things to keep in mind. Single web logins across multiple machines are a definite possibility, or are probable, actually. And you should always take into account that even though Gears secures your data per OS login and per domain, you may have users who share an OS login to access your web application, so you should treat that and deal with that accordingly. Worker pool threads are sweet when offloaded to offload expensive processing. If we were indexing that information on the UI thread, Firefox would pop that, this script is taking too long, do you want to cancel it? And we don't want that to happen, so it's great to leverage that. I'm hoping, we'll continue to see things like that be integrated in the browser. And should really get excited about Gears. And I'm excited about it because I'm talking about it. But you guys should really get excited too, because I think it's really Gears and other like HTML5 things are really ushering in sort of the next generation of web application development and providing us with tools that really make our applications better. And so I hope, in summary, that this kind of gives you an idea that MySpace takes technology seriously. I mean, our founders are very serious people. It's a very serious picture. And so I want to make sure that comes across. Like we want to embrace open technologies. We're embracing open social. We're working with the Gears team to build products that help bring Gears to ubiquity. And we really want to move that forward. That's really it. So if you guys have any questions or comments, feel free. If you guys do have questions, there's 2 mics here. So come up to the mics and ask them, or comments. You can make fun of my code if you want. Or you can talk to me offline. I think I'm going to go over to the Gears table after the session. And that's really it. Any questions? Oh, sweet.
What's the URL?
Oh, the URL.
You mentioned you're going to give it to us.
Oh, yeah. He's asking what's the URL. I'm assuming for the code. Yes. Let me ixnay the presentation, and I'll put it up real big. So that's the URL to the. Let me plus it up a little bit. Zoom in. So that's the URL to the main source, and also there is I can give you the URL to the workers. So I hope that answers your question. I'll get to. Does anybody have any other questions?
I'm really excited about those features too, and the things you could do with it. But I think lots of the things you could build with it will need some kind of synchronization between offline data and online data. So probably there should be a library sort of supplying that. Or looking at your code, I think most of the work went into synchronizing the offline messages with.
So you're asking if there's a library that's available, or you think it's a good idea that there's.
Yeah, I guess so. Since it doesn't really matter what the type of data is, but you sort of need to get it keep it in sync. So.
Yeah, I completely agree. So his question or statement was that it would be really helpful to have a library to help deal with synchronizing data from the server and the client. And there isn't really a common one that I'm aware of currently, but I've talked to some of the members of the Gears team, and that's something that they're aware of as well. And so hopefully in the future, either toolkits like Brad Newberg, the guy I mentioned, he works closely with the Dojo team, so maybe they might have something in their toolkit, and hopefully others will follow suit. So that's a really great statement. What can I?
Hi. You were mentioning that there were some restrictions on the domains and what domain names could access the database. I'm assuming it's kind of like, how when you load a JavaScript, it can only do something from the domain you loaded it from. So does that mean like the MySpaceCDN.com, that domain, if you're loading the JavaScript that interacts with Google Gears, is it that domain that is used for imposing that security restriction, or is it the domain of the overall web page?
So that's a great question. So your question was does the domain that you load your JavaScript from, is that the domain that the same origin policy applies to, or is it the domain in which you browse to? That's actually a good question. It depends. So if you're loading your JavaScript from a script tag, then the same origin policy applies to the domain in which you've browsed to. So if I go to messaging.myspace.com, whack, whatever, but I load from x.myspace.cdn.com, that JavaScript coming from the script tag honors the same origin policy for messaging.myspace.com. Now, conversely, if I use the worker pool load worker from URL, and if I housed my worker thread code on x.myspace.cdn.com, the same origin policy that it would be putting in effect would be x.myspace.cdn.com. That's why the worker pool code actually has to be housed on the URL in which you're loading your web page from. Does that answer your question?
Yeah, thanks a lot.
Sure.
Yeah. One little question. To give an idea, how long and how many people worked on this feature, this messaging search?
Well, the initial prototype was done by one guy, Dan, who you saw, and then the transition to turn that from a really sweet prototype into a full-fledged product on the application side was me, but I also had help on the data services side from a few guys on our data services team. So they implemented the SQL-related stuff, like the trigger that logs whether or not you've updated information and whatever, because I'm not a SQL guy. But from an application perspective, it was just me. Thank you.
Actually, you mentioned one of the things about the web services endpoint, trying to basically download and synchronize the information from the server down to the Gears local database.
Mm-hmm.
So what is the predominantly, the applied convention? So do you use a RESTful services, or is it a SOAP-based web services for communicating with the?
So the question was, what protocol or methodology did we use for the web service? It was kind of a roll your own. It was basically you pass in information via GET request, and it returns results via JSON. So it didn't really follow. It wasn't very RESTful, but it definitely wasn't SOAP. Like, we're not passing back XML or anything like that.
Hi. I was just wondering, so the search was really cool, and I was really impressed with that.
Great.
I was wondering kind of what are the limits of how far that can go? Like, supposing you had, I don't know, like 10,000 or 100,000 messages, or what's the point at which the response would kind of get sluggish?
Well, that's a good question. So the question was, at what point does the local full text index get sluggish? And we haven't hit that point yet. I mean, granted, I haven't been testing with users with 100,000 messages, but I have tested with users with 10,000 messages, and it's still lightning quick. And that's a tribute to, I don't know if he's in the audience, but Scott and the Gears team. That's a tribute to them.
Yes, hello. I was wondering, how do you deal with, I would say, load problems? Do you have any issues where people are pulling down many, many thousands of messages and you're storing them locally in their SQLite database, or have you had any issues with that?
So the question is, how do we deal with load problems? And I guess the answer is we throttle primarily. So we throttle on the client. So if people are using the application as they should, it's aware of how many messages it's expecting, and if it doesn't get that many, it exponentially backs off. So the next request is, we do it every 30 seconds, so the next request would be 30 times 30 seconds. And on the server, we also record that information, and throttle at least to every 30 seconds. So we don't exponentially back off on the server, but throttling is our primary scenario. Now that being said, we only throttle per user machine pair. So if somebody could theoretically farm out and make a bunch of requests, and we wouldn't be throttling. But at that point, I put faith in our application platform and our databases to be able to handle the load.
Well, actually, I guess my question is then, are you allowing the users to store all of their messages locally?
Oh yeah. So the question is, are we allowing them to store all of their message locally? And the answer is yes. Yeah.
And on that, when you are loading messages in from the server, is it loading one message at a time from the server? Because I noticed when you were doing the demo, it was like 1, 2, 3.
Oh.
Is that like processing on the worker pool, but then when you do a GET request to get all your messages, is that 100 at a time or something like that?
So the question is, are we making actual requests to the service for every message, or are we batching them and processing them? And the answer is we're batching them. So the request says, hey, I want to get up to 100 messages from the server. It returns up to 100 messages in JSON, and then that JSON gets passed to the thread. And the reason why it takes some time is because we're transactionally updating all five tables at that time.
Okay. And so how big is like one packet of 100 messages? Like how long would that take to download in itself, do you think?
That's a very good question. I mean, so the question was how big is the packet of messages, and it can vary from user to user, right? Like our users, each message is similar to email, and we don't store things in a threaded fashion. So things replies get appended to the end, and so depending on the use of mail itself, kind of, and when you're doing heavy replies, can vary the payload. And I haven't actually gathered any metrics on that, but that's actually a good thought. I'll do that. Any other questions? Got 7 more minutes of me. Say that one more time. Oh, yeah. So Alan, my boss's boss, wanted me to let everybody know that these URLs that I'm posting up here, I'll also blog on developer.myspace.com. So if you guys are interested and don't feel like writing this down at the moment, they'll be up there probably today or tomorrow. Yeah, now it's on.
This is playing devil's advocate here. Google, with their Gmail, also has a search function. Why don't you just use Gmail's code and then just rebrand it and do a deal with them? Why did you sort of re-roll the
Well, so the question is, why didn't we do a deal with Google and ask them to search for us? And I'm not sure of the answer, actually. But to touch on that point, this is really just a first iteration, and we are actually toying around with the idea now of performing server-side search. We have an internal search team that provides search for several of our features, and they were really excited about this, and they wanted to start actually offering search on the server side too. So hopefully the combination of the two will provide search ubiquity for. I'm using that word ubiquity quite a bit. I don't really understand why. But yes. So I'm not sure is the answer. Anything else? Yes.
Have you had to do any data migrations or schema changes on the client, and how do you deal with that?
That's a very good question. The question was, have you had to do any data migration or schema changes on the client? And thankfully, not yet. Now, that is one of the big things that is a concern, particularly when you're bringing in offline applications offline, is when you need to make a change locally, how do you do that effectively? And the Gears team has had some really good ideas that we'll hopefully leverage when we need to do that, but we haven't had to do that yet, thankfully. Well, on that point, though, one of the things that I've talking about that, the full text, it's more challenging from what I understand to migrate full text from one table to another, but that may have changed. I'll have to ask Scott because he's the guy who is the FT2 guy. Any other questions? You got one? You're just standing and... Sorry.
Yeah, it's a quick question though. So will there be any issues with the amount of data you need to store on the local? Let's say you have so many messages, so will there be any concern storing that much data on the local machine?
So your question was, are there consequences?
Will there be any limits Gears imposes on the how much data you can store, or it's just the user preference?
So the question is, are there limitations to how much data you can store locally? And currently, from what I understand and reading the documentation and talking to the team, is no. I mean, the only limitation is your disk space, theoretically.
So what happens if you run out of disk space? How do you handle that?
That's a very good...
Let's say the user doesn't have enough space, so will that handle gracefully, or because especially you're searching locally, once you run out of space, how do you inform user that you don't have any space?
That's a very good question. Like from a programmatic standpoint, I haven't seen any hooks to be aware of, to be told when we're running low on disk space from the plugin. That actually might be a good thing for them to add, but. I'm not exactly sure how they handle that, because at that point it's the plugin that's doing it. Maybe it throws huge exceptions. Maybe it just doesn't insert. I'm not entirely sure. But there are plenty. A lot of the Gears team is doing sessions, and they'd be great people to ask.
So now everything your mails is like 30 seconds lag. Is that true? Even though the user refreshes, it pulls only like every 30 seconds? Yes.
So the question is, even if the user refreshes the browser, does it still throttle and only pull every 30 seconds? And the answer is yes. In the user settings table in the local schema, we store a timestamp of the last time they made a request, and we basically set the timeout of the next request based on that timestamp. So if they refresh, we grab that information to make sure that we're throttling. And also the server deals with throttling too. So if it receives a request too early, it doesn't make the expensive batch request call. Thank you.
But you don't have the offline support yet, right?
No. So we currently. So the question is, we don't. Do we have entire offline support? And the answer is no, not yet. Although I'd like for that to happen at some point.
Okay. Thank you.
Thank you. I got 2 minutes. Anybody? No? Yeah? No? Okay. Well, thank you very much. I really appreciate it. You guys have a good day.